Physics 30s. It's Thompson here, page 117 of the workbook, Unit 5. Bohr model of hydrogen, 1913. We combine classical and quantum theory together. Orbital radii and energies are quantized, so electrons can only be located at certain radii, but not in between. If the electron remains at an allowed orbit, it will not emit electromagnetic radiation despite its acceleration. Even if it's moving at constant speed, it's changing direction, therefore it's accelerating. The lowest possible orbit is given n equals 1. It's the lowest energy state called the unexcited or ground state, which is other orbits are called excited states, and they are unstable. Okay, and it says each allowed orbit, called a stationary state, has a required energy level. The electron must have the exact energy to be there. The energy levels Bohr calculated are shown in the energy diagram. All right, so you can see here, right? We'll just talk about the diagrams for a second here. We have the nucleus, and then, of course, the n equals 1 level, n equals 2, and then n equals 3. Right? The nucleus contains the protons and neutrons in more complex atoms, and in hydrogen, deuterium, and tritium. But in the nucleus, there's generally just one proton for hydrogen, right? That's what makes it hydrogen. But these are the orbital states where electrons can exist, okay? All right, so it says here, note, when the electron goes beyond n equals infinity, it leaves or ionizes the atom with kinetic energy. The minimum energy to remove an electron from the atom, i.e. to get it to n equals infinity, is called the ionization energy. So as mentioned about here, the energies for the Bohr model are shown right here. So the n equals 1 level is at negative 13.6 electron volts. So if you added 13.6 electron volts to an electron in that state, then it would be ejected from the atom or would leave with 0 kinetic energy. And so negative 3.4 eV, negative 1.51 for n equals 3, and so on, okay? Now, these energies are always negative here because the electrons are bound. They're trapped to the atom, okay? Electrons are in uniform circular motion orbits. So his model is all about them moving in these perfect circular orbits. Electric force of attraction between the proton nucleus and the electron is what holds the electron in orbit. That is, the electric force is the centripetal force. And it's a center-seeking force, right, for the electron directed towards the proton in the center. So we have F net equals ma, Fe equals m times ac, electric force equals centripetal force. And we can substitute in from Coulomb's law, the electric force is kq1 q2 over r squared, and for centripetal force, mv squared over r. And of course, you can see here, since the charge of the proton and electron are identical, then we just, instead of q1, q2, just put q squared, where q is the elementary charge. All right, energy transitions. EMR is emitted or absorbed only when the electron jumps orbits. Quantum leap. A good show from back in the 80s. Google it, check it out. Anyways, we have, of course, a photon emitted when an electron drops from an upper level to a lower level, shown here as EU to EL. And a photon can be absorbed when only the exact amount of energy is provided to the electron. It jumps up from one energy level to another and absorbs that photon. The photon ceases to exist. Based on the law of conservation of energy, the energy gained or lost by the electron, called the transition energy, delta E, must be equal to the photon energy. So the change in energy for the electron is equal to the energy of the photon, where, of course, the change in energy of the electron is the upper energy level subtract the lower energy level.